Hi, today we're going to be proving quadrilaterals in a coordinate plane. If you haven't already, go ahead and write in your notes these formulas: the slope, the distance, and the midpoint. We're going to need that information. In this first example, we are given a coordinate plane that has a shape on it of a quadrilateral. We're asked to prove whether or not this quadrilateral is a rectangle. So what we're going to do is we're going to use the slope formula first. When we do that, it might be helpful for you to go ahead and try to label your coordinates with x sub 1, y sub 1, and x sub 2, y sub 2. Because remember, the slope formula is going to be rise over run, and we already know that if you're rising, that means you're going up or down. So therefore, you want to have the y values on top. And if you're running, you're going left or right, and so therefore you want your x values on the bottom. So now I will just simply substitute in for my y sub 2, but my formula says subtract, so I'm subtracting 3. And then for x sub 2, I am going to subtract a negative number, so pay attention to those details. When I do that, now all I have to do is simplify. 8 minus 3. And now I have to recognize that I have a negative times a negative, which is going to turn into a positive. So negative 1 plus 4 is 3. So now I want to just continue on through the rest of my segments on this shape, and then we'll see what happens. What I see is segments TI and EM have the same slope, which tells me that they're parallel, because we know that if you have the same slope, your sides are going to be parallel, or your lines will be parallel, sorry. What I did here is what I'm doing is trying to show you how to remember. So parallel has an A, and so does the word same. So I'll notice that opposite sides in this shape that's shown on this coordinate plane are in fact parallel, because opposite sides have the same slope. I also noticed something else. If you look at segment IT and segment IM, you'll notice that they were perpendicular. So what happens if they're opposite or negative reciprocal is that you will see that the numerator and the denominator will flip, and the sign in front will change. So the opposite sides are parallel and the consecutive sides are perpendicular. So now we want to take a look at the midpoint. I'm going to use the midpoint to focus on my diagonals. So I'm going to look at segment IE and segment TE. If you recall, the formula for the midpoint is going to take the average of your x coordinates and your y coordinates.
Oh boy.
Negative 1 plus 6 divided by 2 is going to result in 5 over 2. And then 8 plus negative 3 over 2 results in that same 5 over 2. Now this does not mean that the x and the y values have to be the same. What it means is that both of your diagonals have to be the same in order for them to bisect. So I'm going to do the same thing for segment TM. And I'm going to substitute in my x values in the first slot, and I'm going to divide by 2. After, of course, label it. So x sub 1, y sub 1, x sub 2, y sub 2. And just substitute, put my x's together and add them. Divide by 2. I'm taking the average. And the same with my y values. Once I simplify it, I recognize that I have the same values or the same coordinates, 5 over 2. So therefore I know that my diagonals do in fact bisect. In addition to the diagonals bisecting each other, I also show you the parallel lines, the symbols. So if you'll notice, you'll see arrowheads. And notice the opposite sides have the exact same amount of arrowheads. So those are the sides that are parallel to one another.
I guess you were just so misunderstood. You know I'm never truly gone for good.
So for this distance formula, I'm going to substitute in what I've labeled, the x sub 2 and the x sub 1. But again, I can't emphasize enough. In the middle, you are subtracting. So if there is a negative number, make sure that you put that in the parentheses. So you'll remember that you have to go back and change that sign to a positive. Once I simplify, I have negative 7 squared plus 8 plus 3 squared, which is 11 squared. I can further simplify. Negative 7 times negative 7 is 49. And then 11 times 11 is 121. That's what squared means. Just take the number and multiply times the sum. And now I want to further simplify by adding. Square root of 49 plus 121 is the square root of 170. If I were to change this to decimal form, this would be approximately 13.04. That was one diagonal. So now you want to go to the other diagonal, MT. This tells me that my diagonals are the exact same length, which means you have proven that this is a rectangle. Thank you for watching. Please don't forget to subscribe.
Subscribe.